Hi everyone. Today we are going to talk about 8.2 exponential function, but mostly half-life, right? So we are going to write an exponential function in the half-life situations and find out any change in certain time, all right? So what is half-life? Half-life is the amount of time it takes a substance to decay to half of its original amount. It becomes half. It takes so it depending on any situation is different. So so the term is commonly used in the nuclear physics to describe how quickly unstable atoms to undergo radioactive decay or how long stable atoms survive this kind of situations. So look at this, the nuclear plant, right? And nuclear bomb explode, then what's coming out? The radioactive, right? So how long does it stay in the air? That's very important to know. And scientists can use also the half-life of carbon-14 to determine the approximate age of organic objects. They determine how much of the carbon-14 has transformed. They can then calculate the age of a substance, or these things, right? So what will be the common ratio? The half-life situation is an exponential function, right? We know the always for the exponential function, we know so the function looks like 8 times b to the x power. So we know the first initial amount. The next is we should find out what is b, the base, right? The base. How do you find it? So this case, if anything doubles each time, double means what? Increase 100%, right? 100% increase, double. The how do you write down the base? Is a base equal to 1 plus the percentage. Okay, one is, you should just understand, one is from the original portion and the percentage from the increased portion. So 100% increase means 100%. If you convert it to the integer, the number, what is it? 1, right? 100% is equivalent to 1. So 1 plus 100% is 1 plus 1, which is 2. So when anything doubles, the base becomes 2, right? Like this. You get it, right? So base will be 2 when anything doubles each time. Then how about triple? Triple is how many percent increase? 200% increase. Double is 100% increase, right? The triple is 200% increase. So how do you get the base? Again, base is 1 plus the percentage, but 200% is equivalent to 2, which is 3, right? So triple is 3 times each time, right? You multiply 3 times. But today we are talking about half-life. The half means, what is half mean? How many percent increase? Half is not increasing. Actually, it's a decreasing. What then? It's a 50% decrease, right? Then what happened to the base? Base will be 1 is from the original portion, original initial amount, right? From the initial amount, you subtract 50%, okay? That's a 50, it becomes half. So you subtract the 50% decrease, so which is 0.5. If you subtract, it's a 0.5 or half, 1 over 2. That will be the base here, this one. And you know the already the how the function, right? Exponential function looks like this, 8 times b to the x power. You can find out initial amount, how much was the initial amount. You know the base. Then you put this, x must be in the exponent. So put this in the calculator. All right, let's see with the example. Simeon is studying for a big test and is trying to stay awake. He drank a 12-ounce can of a Big Buzz energy drink that contains 80 milligrams of caffeine. He's wondering how long the caffeine will stay in his system if the caffeine has a half-life of 5 hours. Now, while you are reading it, you should figure out, okay, is this exponential function is increasing or decreasing, right? In the same, with the same rate, which is it becomes half, is at half-life, right? So half-life means it becomes half each time. But now here another thing is it's not every unit is not 1 hour. If mostly basic general function was every hour or every 1 hour or 1 month, 1 day, like 1 year, something like that. Unit was like 1, but there's not, it's not unit is 1, it's 5 hours. There's a cycle, right? Then after 5 hours, it becomes half. What was the initial amount in the can? So don't be confused. 12 ounce was not the initial amount. It was a can size, right? But the amount of caffeine was not 12 ounce. How much was it? Yes, 80 milligrams. That's also very important. So how do you write down the equation? But to be, convenient, make it easier. So we made a table. So 0, 1, 2, 3, 4, 5. After 5 hours, it becomes half, right? It goes like that. And then another 10 hours, 5 hours, 10, it becomes another half, right? So you can fill out the table. But caffeine was when the time was 0, it didn't decrease at all. How much was it? 80 milligram, right? And then the cycle, this is half-life cycle. So 0 here, 1 here, it goes like this. So 1, 2, 3, 4, like that. But be careful with the number. Sometimes we want to ask you, they ask you like 16, when the 16 hours later, how much is it? Then you need to know the formula, right? The function. You find the function and look at the table. But now, so even though I say a lot of words, it's simple. You know the function, right? The exponential function, how does exponential function look like? The function look like a times b to the x power. If we use n here, is n power, doesn't matter. So this is the basic shape of the function. We need to know what is a. The initial amount is what? 80, right? And what is b? Base. I explained. Each time it becomes half. So decrease by half, right? So which is 1 minus 0.5, and we know that it's a half. And then it doesn't become half every hour. Every 5 hours, what do you do with the cycle? Here I wrote down n equal to t over 5. So at when the t is 5 hours later, it becomes 1 cycle, becomes 1 half, right? If you don't divide by 5, what happens is when t is 1, it becomes half. Half to the 1 power, it becomes half, right? So when t is 5, 5 over 5 becomes 1 cycle. So that's why you should divide by 5 here. Everybody get it, right? That's the equation. But I will explain one more time here. Look at here. So now, so 80 times 0.5, which is half to the n power. But instead of n, we should write down n equal to t over 5. T is a time, okay? Or you can use x. So n is the cycle here. Each cycle, it becomes half. N equal to 1, so it becomes 40, right? N equal to, you multiply 0.5 one more time there, it's 20, like it becomes half. But actual time, we are not using the cycle. T, 1 hour later, 2 hours later. If you don't change, if you don't divide by 5 again, what happens is when x is equal to 1, it becomes 40. But it's not good. So when x is 5, it should become 40, right? So what should you do? You t divided by 5. So make it simple. So you divide by the cycle from the t or x. That's the your equation. All right. So instead of n, you change it to like this: 80 times base 0.5 or half, and the power. What happened? Only this is a difference, right? When you have a cycle, only this was a difference. Everything was the same. So this one you divide by 5 in the exponent, okay? So x divided by 5 or t divided by 5. But when you put it into the calculator, this t is x, right? So now you know how to put this function in the calculator. You put into the calculator 80 times and half to the x over 5, and then look at the table. If you look at the table will show, look at here. When x is 0, initial number is 80, right? And if you keep going down, when x is 5, first cycle, after 5 hours later, it becomes 40 milligram. And then when x is 10, it becomes 20 milligram. But each hour it becomes decreasing little by little, little by little, and then 5 hours later, 40. Make sense? So so you should look at the next question. Approximately when will the amount of caffeine remaining in Simeon's system be less than 1 milligram? So oh, around when the amount of caffeine become less than 1 milligram? But 20, this is 20, right? Then you need to go down more and more, right? So look at, keep going. If you keep scrolling down in the calculator, then what happened? The next table, if you keep looking down the table, here, if you, when x is 31, still is more than 1, right? But when it becomes less than 1 milligram. So here, when x is 32, right? When x is 32, do you see that? There, it becomes 0.94. For the first time, it becomes less than 1 milligram. So your answer will be 32 hours, not the 31 hours. Everybody understand? So clear about the half-life, right? Only difference is the cycle in the exponent. In the exponent, the x or t will be divided by the cycle. All right, that's the only difference. And put this in the calculator function and then look at the table. You can find out what you want. All right. Okay, we'll stop here.